Professor Bialis here. In this video we're going to be talking about section 3.2, which is graphing linear equations using a table of values. Okay, so when we do that, okay, all we're basically doing is drawing a picture. Whenever we graph a line, that is, we're just drawing a picture of all of the solutions to a linear equation. Remember in the previous section I was saying that a linear equation has an infinite number of solutions. There was a table that they had us fill out in that section that showed us only 3 solutions. And that's great, but that was just a small sampling of all the solutions that are involved. When we draw a picture of a line, there's an infinite number of points on that line. Okay? When we find those 3 and draw the line, we can then point to any other solution that will work for that equation. So let's look at an example. Let's say we have the equation y equals 2x plus 3. Let's say we have something like that. Okay? Now, that is a linear equation because we have an x term and we have a y term. They're not both equal to 0. Okay? When we build our table, okay, table of values, the book will typically have you draw a table like this. And then they fill in the numbers. I personally don't like that because it doesn't give you any room to work. Therefore, your work ends up going all over the place. So what I like to do is build my table around my equation. So I've got an x and I've got y. In the previous section, sometimes they plugged in an x, sometimes they plugged in a y. You can feel free to do that. However, in the long term, when we get into functions at the end of this chapter and beyond, most of the time we will be plugging in an x. We're actually going to be looking at that x as an input. So what I'm going to do is plugging values into x. Now, what values do we plug in? In the previous section, they were always giving you what values to use. But in this section, they don't always do that. If they don't give you what values to use, you get to pick whatever you want, but make it nice. There's no reason to pick a weird number or a big number or a fraction. Just pick a nice value. So in this case, I'm going to go with a 0, a 1, and a 2. That's all. Okay? Now, why did I pick 3? Let me explain that. If I, let's say, draw this point right here, and I ask 20 people to come up and draw a line through that point. Well, they could be drawing any of these lines, and they're still drawing through that point. That's not enough information to get a line. Okay? What if I said, draw a line through those 2 points? Then, if I have 20 people or 1,000,000 people, they're all going to be drawing the same line. That's what I want. I want just enough information to get the job done and be consistent in my solution. So why am I asking for 3 then? Honestly, 3 points, I like using 3 because it's a nice check as we go along. If I'm drawing 2 points here, 2 points, what we say, determine a line. Okay? That's enough information. However, if one of these is wrong, that doesn't look wrong to me. But if I throw a 3rd point in, let's say that, then I can say, wait a minute, something's not right. Because there's no way I'm going to get a straight line through those 3 points. Something's not right, I got to fix it. So when we're doing these tables, I'm looking for 3 points. 2 are necessary. The 3rd one is nice to check. Nothing more than that. Okay? So let's go back to this equation. So we were given this, and we want to graph using a table of values. We're picking 3 x values. Why did I pick 0, 1, and 2? Because they're easy. Nothing more than that. Now what I do is simply plug them in and calculate the corresponding y coordinate. So let's do that. I've got y equals 2 times 0 plus 3, y equals 2 times 1 plus 3, and y equals 2 times 2 plus 3. Okay, so 2 times 0 is 0, plus 3 is 3. 2 times 1 is 2, plus 3 is 5. 2 times 2 is 4, plus 3 is 7. And now I have 3 ordered pairs. 0, comma 3 has me go up 3 units. 1, comma 5, I go right 1, then up 5. And notice I am starting at the origin every point. And then I go to 2, comma 7. So 2, 4, 6, 7. And there I have 3 points that form a nice straight line. I connect the dots and I'm good to go. Always use a straight edge when you're doing these graphs. And there we go. Okay. Now, I found 3, but any other point along this line would give me another ordered pair solution to that equation. It's important that you put these arrowheads on both sides because that line does go on indefinitely, giving you those infinite number of solutions. Okay? Let's look at another one. Now this is more of the standard form of a linear equation that we were introduced to in the previous section. Okay? Now, what I will say about this is when it is written in that form, don't jump into a table. The reason being, if I did that, let's say I picked, let's say 0, 1, and 2 again. Okay? The problem with that is if I plug a 0 in, and then a 1, then a 2. I have 3 of the exact same equation that I need to now solve algebraically. I don't want to have to do that if I can avoid it. So when you are graphing with a table, the first thing I want you to do is solve for y. The previous example we had was really easy because the y was already by itself. When we plugged in the x, it was just calculate, calculate, calculate. There was no algebraic solution that we were looking for. So that's what we're going to give ourselves in this situation here. So again, if they give you a linear equation that does not have y by itself, get y by itself first. Okay? So what I'm going to do here is I'm going to subtract x from both sides. And then I could write 6 minus x. That's not wrong. However, when we get into slope-intercept form in the next couple sections, it's really important that you start the habit of putting the x first. So I'm going to write this as a negative x plus 6. Again, put the x first for later. That's an important skill and habit to have for later. Another habit I want you to start forming is when I divide this 3, don't divide that whole thing. Divide each term individually. Again, for later. I then get y equals, I'm going to write negative 1/3 x plus 2. Because there's that negative 1 and I just kick the x out to the side. Okay? So what I have here is the same equation but rearranged so y is by itself. This now gives me something I can work with. I solved it once and I don't have to solve it again. Okay? The previous way that I was going to attack this, I would have had to solve that same equation 3 times. In this case, I do it once and I'm done. The other good thing that this shows us is that there's a fraction here. If I didn't see that, I wouldn't necessarily know that there was going to be a fraction that I would encounter halfway through. If I can avoid graphing fractional points, I want to avoid it. Not that it's wrong, but if I have to graph a 1/2 and then a 1/3 and I'm somewhere here, I had to approximate that. And the more approximating I do, the less accurate I am. So what I want to do is get the y by itself so it's easy to calculate, and also I can see that fraction. Now, when I see the fraction, how do I take care of it? Okay, I want to plug a value in here that when I multiply it by the negative 1/3, the fraction eliminates. Now remember, in equation solving, how did we eliminate fractions or clear fractions? We were multiplying with a common denominator. So that denominator is a 3. So I'm going to pick numbers like 3, 6, 9, -3, -6, -9, and always a good one, 0. Okay, because 0 will just cancel out whatever it's multiplying. Okay, so I'm not going to pick 0, 1, and 2, because if I put a 1 there, I'm going to be left with a fraction that I have to deal with. I'm going to pick 0, 3, and let's say -3. Okay? So again, if you want to generalize this, you can pick 0, the denominator, and then the negative of the denominator. Okay, that will work every time. So I get that. Okay, and now look how nice this works out. 0 times anything is 0. Plus 2 is 2. 3's are gone. I got -1 plus 2 is 1. No more fraction. 3's are gone and the negatives cancel out. So I got 1 plus 2 is a 3. And I got nice clean values. So what I plot, 0, 2, 3, 1, and then -3, 3. I get a nice straight line out of those points. Put my arrows on there, and I'm good to go. Okay? Okay, let's look at another one like this. Let's say we have 5x minus 2y equals 8. Okay? I want you to pause the video now, and I want you to try and solve that for y. Okay, now when we're solving that for y, I am going to first move that x by subtracting it over. Now remember what I said about that habit I want you to form. Put the x term first. And we got that. Next, I want to divide everything individually by a -2. 2 negatives make a positive. And we have that. Okay? Now, I can create my table. I'm going to look for 3 different x values. Again, I need 2 to get a unique line. I do the third as a check. Okay? Now, what 3 values would be nice values here? I would say 0, then a 2, then a -2. There you go, 0, 2, 4. Whatever will work for your grid. Sometimes you're going to pick a value that's going to take you all the way over here, or all the way over here. If that happens, then pick another point. I am not a really big fan of changing the scale here and saying everything's counting by 2 and so on, because that can usually be avoided by simply picking another value and getting a number that fits. Okay, so let's work this out. I've got 5 over 2 times 0 minus 4 times 2 and -2. We have that. 0 times anything is 0. Minus 4 is -4. 2's cancel, so you got 5 minus 4 is 1. 2's cancel, but remember it's a negative times a 5, so negative 5 minus 4 is negative 9. Okay? So I plot that 0, negative 4. I've got 2, comma 1. And I have negative 2, negative 2, 4, 6, 8, 9. And those make a nice straight line. Connect the dots. And we're good to go. If you use fractional points, there's nothing wrong with that. Just make sure that you are approximating them correctly. Okay? If you're going for a half, don't put it down here. Okay? Make sure that it's halfway in between. Okay? Typically what I like to do is use that half as a gauge. If you're doing this on paper, those graph grid lines are usually not that big. So if you go to the halfway, if it's a little bit more than a half, a little bit below the half, that's pretty much as accurate as you can hope to be when you're graphing these by hand. Okay? Let's look at a couple special cases with graphs that we're going to see again and again in different settings, but I want to make sure that we can start introducing them here for the future. Let's say I give you an equation like this. X equals 2. That doesn't look like a linear equation. Okay, but remember, linear equations have an x and y, or just an x, or just a y. This is a linear equation. Okay, that y just has nothing to do with it. Okay, so let's say we're making a table here. We can't solve for y, but that's pretty simple the way it's laid out already. So if I make a table, I'm still looking for 3 values. Okay, there's no fractions to worry about, so I'm just going to say 0, 1, 2. I can't do that. Because what did the equation say? The equation says x equals 2. Or you could say that as x is 2. The y is irrelevant because it's not in the equation, as long as the x is 2. So what does that look like? X is 2. Y, whatever you want. Let's say 3. X is 2. What's the y? Whatever you want. Let's say negative 4. X is 2. What's y? I don't care. Let's say 1. I have 3 points, all of them with an x of 2. That satisfies the equation. What kind of line is this going to be? If I go 2, comma 3, if I go 2, negative 4, if I go 2, comma 1, I just created what's called a vertical line. And there we go. Okay? So what I want you to get out of this, whenever you have x equals, I'm going to call it c for constant, I am going to have a vertical line. If this was x equals 5, I would go on that x-axis to 5, and I would draw a vertical line. If it was x equals negative 3, I'd go to negative 3 on the x-axis, draw a vertical line. Nothing more to it than that. Now let's say you're looking at that and you're like, oh, I forgot what kind of line he said that was. Now you don't have to just know that off the top of your head. Make a table like I did here. Okay? What if I gave you y equals negative 2 as your equation? Okay? Very similar, but obviously different because we have the y instead of the x. How would a table look with that? Let me use a different color on this. In this case, what doesn't matter? The x doesn't matter. The x could be whatever the heck you want it to be. Let's say it's 1, negative 2, and 5. But what does the y have to be? The y has to be -2. Without any calculation, I made 3 points. What kind of line is that going to give us? Let's say we go 1, -2. 1, -2. -2, -2. 5, -2. And that will give us a straight line, more specifically, a horizontal line. Oops. And there we go. What I want you to get out of that is that whenever it's y equals a constant, you should expect a horizontal line. Y equals 4. I'm going to go on the y-axis to 2, 4, horizontal line, done. If I have y equals -6, I go down 2, 4, 6, horizontal line. Okay? Again though, if you're looking at this, this should be a 2-second problem. However, if you're not sure, if you're like, oh, it's x equals 2, I forgot what that is, then don't just guess. There's no reason to guess. Figure it out. That's the beautiful thing about mathematics. If you're in a history class and you forget a date that something happened on a test, then you're kind of out of luck. Okay? But in math, if you forgot that detail, if you forgot this, you can still figure it out. Use what you can. Know as much as you can going into an exam or whatever situation you're in. Okay? But if you're stuck, if you're thinking, oh, I forgot, then don't just say, oh well. Figure it out. Okay? Think about it. Try to go a different route. It may be longer, it may be more writing, but that's safer than going through this and just randomly picking something. Okay? So, remember when we're graphing with a table of values, we are looking for 3 values. 2 are necessary, a third one is just there to help you check. Okay? But it's a very important piece of it, so make sure 3 points every time. Also, if the equation isn't y equals, make it y equals. So then you only have to solve it once, and if there's a fraction to deal with, you'll know that it's there and that it has to be dealt with. Okay? So, as always, work hard. Let me know if you have any questions, and I'll see you next time.